Hello everyone, welcome back to my YouTube channel. So in this video, let us discuss about transformer construction and types of transformers based on the construction. So transformer construction and types. There are two types of transformers based on the construction of single phase transformer. The first one is core type of transformer and second one is shell type of transformer. So core type of transformer, you can see the construction diagram of core type of transformer. So it is having two limbs, two yokes, and windings which are encircle the core. So this is about core type of transformer. You can see. So it has a single magnetic circuit, only one magnetic circuit it is having. And here the core which is rectangular in shape and it is having two limbs vertical and two yokes horizontal. Here the windings which encircles the core and coils used are of cylindrical type and wound in helical layers with layers insulated from each other. And here the core which is made up of large number of laminations to reduce from the losses. As windings are uniformly distributed over both limbs, the cooling is very effective. The natural cooling we can do it for core type of transformer. So it has only one magnetic circuit. Core is rectangular in shape and it is having two limbs and two yokes and windings which will be encircles the core. The coils are cylindrical type and it is having helical layers insulated from each other to reduce it from the eddy current losses. Core is made up of large number of laminations and windings which are uniformly distributed. That's why the natural cooling is possible. Shell type of transformer, it is a double magnetic circuit. You can see one, this is the first magnetic circuit and this is the second magnetic circuit. Here the both primary and secondary windings which are wound on central limb of the transformer. And you can see it has a double magnetic circuit and the core which has three limbs and two yokes, and in a central limb both the windings which are placed. Here the coils which are generally used a multi-layer disc type. Here the core is laminated and while arranging the laminations, care is taken that all joints or alternate layers are staggered. So for very high voltage transformer, shell type construction is used. So the shell type of transformer which will be used for high voltage applications. And here the natural cooling is very difficult because of the central limb winding wounds. The windings surrounded by the core natural cooling doesn't exist. So here the windings which are surrounded by the core, in case of core, the core encircle the winding. So if we can see that comparison, the winding encircles the core in case of core type, the core encircles the most part of the winding in case of shell. The cylindrical type of coils which will be used for core type, here multi-layer disc type or sandwich coils which will be used for shell type. So as the windings which are distributed uniformly so that the natural cooling is more effective, here the natural cooling does not exist. The coils can be easily removed from the maintenance point of view. Here it is complicated. And the construction is preferred for low voltage applications. In case of core, here it will be used for high voltage application. Core type is having one magnetic circuit. Here the shell type it is having double magnet circuit. Core type is having two limbs, two yokes, and shell type is having three limbs, two yokes. So this is about the comparison and just an idea about ideal transformer. The ideal transformer means it is having no losses. loss-free transformer. It is having 100% efficiency transformer. That is, input power is same as output power. So you can see the ideal transformer is having zero leakage flux. That is nothing but flux produced by the primary and secondary are same. Currents which are confined within the core only, and the windings which will be not having resistance. If there is no resistance, means there is no loss. And the induced voltage is equal to applied voltages, that is primary voltage which is same as secondary voltage. The core has infinite permeabilities. The reluctance of the core is zero here, so that negligible current is required to establish magnetic flux. Lossless magnetic core, no hysteresis or eddy currents. So this is about the ideal transformer. If you're having any doubts regarding core type and shell type of transformer, feel free to write in a comment box. So if you like this video, do subscribe and share maximum. Thank you so much. Have a nice